Today let us look at length of arc of a circle. So what is an arc? It is a piece of the circumference or perimeter of the circle. We could also look at it by drawing two radii, OA and OB. So the piece of circumference between these two radii, that is arc AB. Now let us take two other points P and Q on the circumference of the circle. So arc APB is called the minor arc and arc AQB is called the major arc of this circle. Now let us take a circle with radius OM. Now recall that the area of this circle is pi r square and the area is subtending an angle of 360 degrees at the center. So 360 degrees corresponds to pi r square. Now if we were to take a sector MON such that angle MON is theta, then the area of this sector would be pi r square by 360 degrees times theta degrees. Now let us apply a similar logic for finding the length of the minor arc MN. So now we are looking at the circumference of this circle, which is 2 pi r. Now once again, let us check out the angle subtended at the center. It is 360 degrees. So 360 degrees is corresponding to 2 pi r. Now let us look at the arc created by the sector MON. Now this minor arc is subtending an angle theta at the center. In other words, angle MON is equal to theta. So let us apply the unitary method once again to find the length of this arc. So it would be 2 pi r by 360 degrees times theta degrees, which is the angle subtended by the arc at the center. So we are applying the unitary method for finding area of a sector as well as the length of an arc. Let us look at a few problems. In a circle of radius 21 centimeters, an arc subtends an angle of 60 degrees at the center. Find the length of the arc. So we have a circle of radius 21 centimeters. So let us draw a radius OA. Now we are given an angle of 60 degrees at the center. So let us draw another radius such that it is subtending an angle of 60 degrees at the center. Now we have to find the length of this arc. Note that when we say arc, we are referring to the minor arc by default, unless otherwise mentioned. Now the length of an arc would be 2 pi r, which is circumference of the circle, divided by 360 degrees, which is the angle subtended by the circumference at the center, times theta degrees, which is the angle subtended by the arc at the center. Now let us substitute the values for pi r and theta and simplify. We find that the length of this arc is 22 centimeters. Let us look at another problem. The area of a sector of a circle is 462 centimeters square. Find the length of the corresponding arc if the sector subtends an angle of 120 degrees at the center. So we are given area of a sector of a circle as 462 centimeters square. So let us apply the formula for area of a sector. We know that pi r square by 360 times theta is equal to 462. Now we have to find the length of the corresponding arc. So it is the arc subtended by the sector. So it is a piece of circumference that the sector is cutting. Now we are given that the sector subtends an angle of 120 degrees. So we know that theta is 120 degrees. But we are not given r. For finding the length of an arc, we need both the radius and theta. So let us use the formula for area of a sector and try to find out r. Let us substitute the values for theta and pi, cross multiply, simplify, and we get r square is equal to 21 times 7 times 3. Now let us prime factorize 21. And we see that we are looking at 7 times 3 whole square. Taking square root on both sides, since the radius can only be positive, we see that r is equal to 7 times 3 or 21 centimeters. Now we know r is 21 centimeters and theta is 120 degrees. So we could apply the formula for finding length of an arc. Let us substitute the values, simplify, and we find that the length of this arc is 44 centimeters. Let us look at another problem. A brooch is made with silver wire in the form of a semicircle with diameter 35 mm. The wire is also used in making 4 radii which divide the semicircle into 5 equal sectors as shown. Find the total length of the silver wire required. Alright, so we are given diameter as 35 mm. So radius would be half of that, 35 by 2 mm. Now this is a semicircle. Since it is half of a circle, it would be subtending an angle of 180 degrees at the center, which is half of 360 degrees. And we have to find the total length of silver wire. So we are looking at this arc which is appearing 5 times. So we are looking at 5 arcs. Since the sectors are equal, these arcs would be equal in length. And we also have 6 radii here. So we shall add the length of 6 radii. So here we know radii, but we need to find out the length of one arc. So let us apply the formula 2 pi r by 360 times theta. Since there are 5 equal sectors, the angle subtended by one arc at the center would be 1/5 of the angle subtended by the semicircle. So theta would be equal to 180 by 5. Now let us substitute the values for pi, r and theta. Let us simplify. And we see that length of one arc is equal to 11 millimeters. Now we know the length of one arc and we know the length of the radius. So let us substitute the values and simplify. And we find that the total length of the silver wire required would be 160 millimeters. Note that we are looking at the semicircle and the radii. There was another way to solve this question. In order to find the total length of the silver wire, we could have taken the length of one arc which was subtending an angle of 180 degrees at the center and then added the 6 radii to it. The answer would still be the same, 160 mm.